Hello students, in today's lecture we will see the IV characteristics of SCR, that is silicon controlled rectifier. So in order to study the IV characteristic, the current is plotted on y-axis and voltage is plotted along x-axis. The curve OABC shows the forward characteristics of SCR, while the curve ODC shows the reverse characteristic of SCR. This is a point C and this is a point D, and this is called avalanche breakdown. Avalanche breakdown. Here the point A gives the breakdown voltage. This point A gives breakdown voltage, and after point A, this is the on state of SCR. On state of SCR, where Ig is equal to 0. That is, gate current is 0. So, as there are two type of IV characteristics of SCR, that is forward characteristic and reverse characteristic. First one is forward characteristic. Forward characteristics. When the anode is positive with respect to cathode, then the characteristics are known as forward characteristic. In figure, the curve OABC shows the forward characteristic of SCR, where for this SCR, the gate current Ig is equal to 0. If the supply voltage is increased from 0 to point A, as this is the voltage which is plotted along x-axis, and when the supply voltage is increased from 0 to point A, when SCR starts conducting, at some point when the supply voltage is increased to 0 to some point A, the SCR starts conducting, and under this condition the voltage across SCR drops suddenly, as shown by this dotted line. After this point A, the voltage across SCR drops suddenly, and most of the supply voltage appears across the load resistance RL. If the proper gate current is made to flow, the SCR can close at much smaller supply voltage, and at this point B, the SCR turns on, and this line BC shows the on state of SCR. So this is all about the forward characteristic of SCR. Then next one is reverse characteristic. reverse characteristics. When the anode is negative with respect to cathode of the SCR, the curve between current and voltage is known as reverse characteristic. The reverse voltage does come across the SCR when it is operated in AC at it is operated with AC supply, and if the reverse voltage is gradually increased at the first time, the anode current remains small. This is the value of anode current, which is very small. This is I. As voltage increased, but the value of current is small at some point C. And this anode current which remains small, it is called as leakage current. So this value is known as leakage current. This is leakage current. And at some reverse voltage, the avalanche breakdown occurs. So this curve CD shows the avalanche breakdown in the SCR, and the SCR starts conducting when avalanche breakdown occurs. It starts conducting heavily in the reverse direction. That is when the SCR is operated with the AC supply and voltage is supplied in the reverse direction. At first voltage increases, but in reverse direction we observe the small current, and which is known as the leakage current, and after some point C, the avalanche breakdown occurs and the SCR starts conducting heavily in reverse direction. The maximum reverse voltage at which SCR starts conducting is known as reverse breakdown voltage. So there comes the entity reverse breakdown voltage. Reverse breakdown voltage. So it is the value of that voltage at which the SCR starts conducting heavily. So this is all about the IV characteristic of SCR. Now we will discuss some points for the SCR in the normal operation. So there are some points which must to be taken into consideration for the normal operation of SCR. So the next point one has to take into consideration is SCR in normal operation. SCR in normal operation. So the first point one has to take into consideration is that the supply voltage is generally much less than the breakover voltage. Then the next point is the SCR is turned on by the passing appropriate amount of gate current and not by the breakover voltage. The third point is when SCR is operated from AC supply, the peak reverse voltage which comes during the negative half cycle should not exceed the reverse breakdown voltage. Then fourth point is when SCR to be turned off from the on state, the anode current should be reduced to the holding current. And fifth point is if gate current is increased above the required value, the SCR will close at much reduced supply voltage. So with this I will stop here. Thank you.